Hi guys, let's look at the next question. The next question that we do is question number 11. But before we start with the next question, let us quickly revise what is this chapter about. Part 1, we talked about midpoint theorem. So in midpoint theorem, if you have a triangle and you have two midpoints which are given, which means what is given is D and E are midpoints. So D and E are midpoints. Then what we get is DE is parallel to BC and DE is equal to half of BC. This was midpoint theorem. Perfect. And then we did a converse of this. In the converse, what we had was one midpoint was given and a line which is parallel is given. So let's say this is D, this is E, A, B, C. What was given was D is midpoint, so D is midpoint, and what was given was DE is parallel to BC, and what we get is E is midpoint, and the second part remains the same, which is DE is equal to half of BC. So this is converse midpoint theorem. Perfect. And the second exercise that we've done now talks about equal intercept theorem. So as per this equal intercept theorem, if there is a pair of parallel line and if this is there are two transverse, let's say transverse one is A, B and C, this is D, E, F. What it says is if AB and BC are equal, what is given is these three lines are parallel. If AB and BC are equal, then DE and EF will also be equal. So it says what is given is AD parallel to BE parallel to CF, and what is also given is AB is equal to BC. So what we get is DE is equal to FE. Perfect. So this is what we get. Now let's move on and let's solve some questions. So we are now on question number 11. So let's look at question number 11. AD and CE are medians, which means BD and CD is equal. So let's write this down. AD is median, which means BD is equal to CD. And CE is also median, which means AE is equal to BE. This is given. Next, DF is parallel to CE. DF is parallel to CE. This is also given. Right. Now we need to prove that FB is equal to 1/4 of AB. FB is 1/4 of AB. So I have a midpoint, which is F is the midpoint. No, F is not the midpoint. I have a midpoint which is D, right? And I have DF which is parallel to CE. So if I look at my triangle BEC, then I can look at one midpoint and one parallel line, which means I can prove that F is midpoint of BE. Perfect. So this will help us in getting something. So now let's start looking at the question. So in triangle BEC, what do I have? Number 4, B is midpoint of BC, and number 5, DF is parallel to CE. This is given. So using converse midpoint theorem, what I get is number 6, which is F is midpoint of BE. What it basically means is BF is equal to FE, and number 7, FD is equal to half of EC. These are the two things that I get from getting this, right? Using converse midpoint theorem. So I already know that AE and BE are equal. Now I know that BF and FE are equal. So let's see if I can get something from this. So BE would be equal to BF plus FE, which means BE is equal to BF plus BF. Why? Since FE is equal to BF from 6. Therefore, BE is equal to 2 times FB, right? So I'll write it as 2 times FB. They want FB, so I'm writing it in the form as given, as required in the question. And let me see if I have a relationship between BE and AB. Yes, so from 2 and 9, I get AE is equal to BE is equal to 2 times FB. Now I know AB is equal to BE plus AE, which means AB is equal to, instead of BE I am writing 2FB, and instead of AE I am writing 2FB from number 10. Therefore, AB is equal to 4FB, which means AB upon 4 is equal to FB. That's what they wanted me to prove, so we've done this. So let's revise this question. What we basically started was with this triangle BEC. Why did I look at this triangle? Because I found one midpoint and I found one parallel line. Perfect. Let's look at the next question. The next question that we do is question number 12. Let's look at question number 12. In parallelogram ABCD, E is the midpoint of AB and AP is parallel to EC. So let's try and draw a rough diagram first. Okay. So this is my parallelogram that I'm looking at. Here. Okay, let's join this and let's join this. Perfect. So I have A, B, C and D. E is the midpoint of AB. So let's say this is E, this is the midpoint of AB. Next, AP is parallel to EC. AP is parallel to EC. So let me first join E and C. And AP, where is AP? AP is parallel to EC, which means BC at O, okay, and BC produced at P. So I am basically producing BC for the something like this. Let's see where it will meet BC produced, and I have AP is parallel to EC. Okay, so this is a line which is parallel to EC, something like this. Perfect. So I can erase this part, not required. So this is AP and it meets DC at O and it is parallel to EC. Perfect. Let's read the question again. In parallelogram ABCD, I made this a parallelogram, which means this side and this side are equal and parallel. E is the midpoint of AB marked. AP is parallel to EC. AP is parallel to EC marked, which means DC at O marked, and BC produced at P. Perfect. Prove that BP is equal to 2AD. So let's look at which triangles I can look at. BP is equal to 2AD. So I notice that, let's look at this big triangle. I have one midpoint and I have a parallel line. Perfect. So now I think I can look at this triangle, which is triangle ABP, which will help me do something. So in triangle ABP, let's see what I know. Number one, E is midpoint of AB, and number two, I have EC is parallel to AB. EC is parallel to AP. Perfect. Both of this is given, which means using Converse midpoint theorem, let's see what I get. If I use Converse midpoint theorem, what I'll get is O, or rather C would, so this is ABP, one midpoint, so C would be the midpoint. So C is midpoint of BP. What it means is BC is equal to CP. Let's mark that. BC is equal to CP. But I already know that BC is equal to AD, so let me mark that as well. Why is BC equal to AD? Well, because these are opposite sides of a parallelogram. So that this is something that I get. Number 4 that I'll get would be EC will be equal to half of AP. Why? Yeah, Converse midpoint theorem, E and C are midpoints and EC will be half of AB. Perfect. What I need to do is BP is equal to 2AD. Now, where is BP? BP is equal to 2AD. I think I've already got my answer. So, number 5, BP is equal to BC plus CP. And BP will be equal to BC. Instead of BC, I write AD. Why? Because BC and AD are equal. They are opposite sides of a parallelogram. Plus, instead of CP, I'll write BC. Right? Okay, yeah, why? Let's just write this down. The reason would be since BC is equal to CP from 3 and BC is equal to AD. Why? Opposite side of same parallelogram. I think I should have left more space. Anyway, doesn't matter if you've got the reason correct. So, which means number 7, which is BP, is equal to AD plus AD. Why? Since BC is equal to AD. We just wrote the reason in the last one. So, this means BP is equal to 2 times AD. Perfect. So, this first part is done. Next, I need to prove that O is midpoint of AP. So, I need to prove that O is midpoint of AP. Now, I know C is midpoint and I know DC is parallel to AB. Perfect. So now I can again use Converse midpoint theorem. So let's start writing. Number 9, which triangle are we looking at? In triangle ABP. Once again, number 9, C is midpoint of BP. Where did we get this? This is from 3. And number 10, CO is parallel to AB, which is opposite sides of parallelogram ABCD. Perfect, which means using Converse midpoint theorem, I get number 11. Let me just mark a line here. So this is the previous one, and I didn't basically do a neat job. Doesn't matter. Question part 11. If I use Converse midpoint theorem, I get O is midpoint of AP. Right. So if this is midpoint and this is a line parallel, which means O would be midpoint of AP. Perfect. So I've got my second part as well. That finishes this question for me. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.